morning. So today we are continuing the last class what you have studied, that is Cauchy's root test. Clear? Cauchy's root test what we studied in the last class. Some problems, 3 or 4 problems I have solved using the Cauchy's root test. Last class we have discussed some methods of how to use Cauchy's test when there is n power n this type. We can use for a problem, you can use both D'Alembert's ratio test and Cauchy's test, whichever easy for you. But sometimes if they ask in the question, use Cauchy's root test, then you have to use Cauchy's root test. If they ask use D'Alembert's ratio test, then you have to use D'Alembert's ratio test. D'Alembert's ratio test, we have solved enough number of problems, and you have seen that the concept of D'Alembert's ratio test is un plus 1 divided by un. Limit n tends to infinity, un plus 1 divided by un. If it is less than 1, the given series sigma un converges. If it is greater than 1, the given series sigma un diverges. And if it is equal to 1, the test fails. Similarly, for the Cauchy's root test, Cauchy's root test, we take it as un power 1 by n. The given series sigma un, we find its nth term, that is un, and we take un power 1 by n, and that is called as the Cauchy's root test. Okay, then we use all the methods that we solve and the basics of limits what you studied in first semester, that is M1, and your PUC, especially the limits of n tends to infinity will be used in these concepts. It's very simple. Solve the problem, same problems given in the notes, and master it. Then you can try for other problems, model question problems, etc. So now we discuss. I had given one problem for homework. I don't know how many of you had tried it. Okay. So test for convergence the series. Sigma n is equal to 1 to infinity. Okay. Sigma n is equal to 1 to infinity. N cubed by 3 power n. N cubed by 3 power n. So test for convergence the series sigma n is equal to 1 to infinity n cubed by 3 power n. Okay, now sigma un is equal to, we take the series, and this is the problem on Cauchy root test because we are discussing the concept of Cauchy root test. Now here sigma un is equal to sigma n is equal to 1 to infinity n cubed by 3 power n. Sigma un, let sigma un be equal to sigma n is equal to 1 to infinity n cubed by sigma n is equal to 1 to infinity n cubed by 3 power n. Okay, sigma un is sigma n is equal to 1 to infinity n cubed by 3 power n. Okay. Now the nth term un is equal to n cubed by 3 power n. Okay. Then the Cauchy's root test means limit n tends to infinity un power 1 by n. Limit n tends to infinity un power 1 by n. Cauchy's test is limit n tends to infinity un power 1 by n. So limit n tends to infinity, in place of un I write this, that is n cubed by 3 power n whole power 1 by n. Here, it's nth term. Now what happens here, a by b power m is a power m by b power m, the indices, the powers can be multiplied, 3 into 1, that is 3 by n power 3 by n divided by n into 1 by n get cancels 3. So limit n tends to infinity. Okay, now here what happens, limit n tends to infinity, 3 by infinity, any number divided by infinity, I told many times, is 0. So naturally any number power 0 is also equal to 1. So n power 0, that is equal to 1, or infinity power 0 also 1 by 3. Okay, or you can also use here limit n tends to infinity n power 1 by n equals 1. This formula, see, limit n tends to infinity n power 1 by n is equal to 1. Using that formula, limit n tends to infinity n power 1 by n is equal to 1. 1 power 3 will be 1. This formula is there. Limit n tends to infinity n power 1 by n equals 1. So here limit n tends to infinity n power 1 by n is 1. 1 power 3 is 1. So 1 by 3. Okay. So here it implies limit n tends to infinity un power 1 by n equals 1 by 3. limit n tends to infinity, un power 1 by n is equal to 1 by 3 and that is less than 1. Limit n tends to infinity, un power 1 by n is equal to, you got your 1 by 3 and the value 1 by 3 is always certainly less than 1. So if it is less than 1, by the rules of Cauchy's root test, sigma un is convergent. Because it is less than 1, by the rules of Cauchy's root test, the series sigma un is convergent. Now we discuss another problem, that is question number 5 in Cauchy's root test. Discuss the nature of the series 1 by 2 plus 2 by 3x plus 3 by 4 squared x squared plus 4 by 5 whole cubed x cubed to infinity and x is positive. Again I repeat, discuss the nature of the series 1 by 2 plus 2 by 3x plus 3 by 4 whole squared into x squared. Here there is the plus sign here, a plus sign is missing here. 4 by 5 whole cubed x cubed plus etc. to infinity x greater than 0. Okay, what we do, first we write the given series as it is given in the question. We write it as it is given in the question. Clear? We write it as it is given in the question. So here sigma un is equal to 1 by 2 plus 2 by 3x plus 3 by 4 whole squared into x squared 4 by 5 whole cubed into x cubed plus etc. to infinity. So you can see here the first term is x power 0. X power 0 is 1. X power 0 is 1. So here what happens? 0. 0 plus 1 is 1. 0 plus 2 is 2. So x power 0 is 1. So this will be the nth term you have to guess. You have studied how to do nth term in your 10th standard in arithmetic series, geometric series and harmonic series. So here what happens, if you see the first term, this is the first term. So neglecting the first term x power 0, because it's a constant, you neglect it. We start first term from, because x power 1. So x power 1, if we take n1, 1 plus 1, 2, 1 plus 2, 3, raised to the power of 1 into x. Okay. This will be the second term. Neglect the first term because x power 1. Then this will be the second term. So n equals to 2 plus 1, 3, 2 plus 2, 4. Then n equals to, so like this. So this will be the nth term. So guessing the nth term in the problem is only, it takes some time. How to judge that this is the nth term or whether it is not the nth term, like that. Sometimes it will be in arithmetic progression, sometimes it will be in geometric progression, sometimes it will be in harmonic progression. Sometimes you have to use your common sense and put n values like that. Now here it is not in the, okay, numerator you can see 1, 2, 3, 4, but this I start first term from here. So this will be the first term. So I took n plus 1 divided by n plus 2 whole power n into x power n. So I neglected the first term, if it is clear. So first method is finding the nth term. If there is 1 mark or 2 mark for the nth term. If the nth term is wrong by itself, then the nth term is wrong means the full problem will be wrong. You will not get any marks. So first nth term should be correct. Nth term, you have to see the pattern of the given series, each term, first term, second term, third term. And when the nth term, once you can also trial and error method, you can check it. Once you are sure that this is the nth term, then we use Cauchy's root test. Once you are sure that it is a the nth term is correct, then we use Cauchy's root test. So what is this Cauchy's root test? So limit n tends to infinity, un power 1 by n. You have to take limit n tends to infinity, un power 1 by n. That is limit n tends to infinity, n plus 1 by n plus 2 whole power n into x power n whole power 1 by n. The nth term is written here. So limit n tends to infinity, n plus 1 by n plus 2 whole power n into x power n whole power 1 by n. Now we simplify this. So how to simplify? See, by a into b power m is a power m into b power m by using the rules of indices. When this term raised to the power, the powers are multiplied, n and n get cancelled. So n plus 1 by n by 2 power 1. Here x power n whole power 1 by n and n get cancelled. So into x. Now we have to find the limit of this as n tends to infinity. As n tends to infinity, we have to find the limit of this. So what happens here? Limit n tends to infinity. You know how to find the limits of infinity. We have studied in your first semester and also in your PU levels. So whenever we want to take whenever we want to find out limits of infinity, we bring n to the denominator. We try to bring n to the denominator. That is, we try to bring the term n to the denominator. So here also, we try to bring the term n to the denominator. So n is removed common, 1 plus 1 by n. This type of ideas you have used many times. Here also, I remove n common, 1 plus 2 by n into x. Now n and n get cancels. When you apply the limit, 1 by infinity is 0. So 2 by infinity is 0. So 1 by 1 is 1 into x. That is x we got. So when we applied the limit n tends to infinity, un power 1 by n, we got it as x. Now we have to check. So whether x is greater than 0, less than 0, like that. So if you given in the problem, it is given x is greater than 0. In the problem, it is given x greater than positive. Okay. So now we have to check it. What happens since it is given to be positive? Now we see here. X here it is. X is greater than 0. So x is positive. So x is positive, you got. So limit n tends to infinity. Un power 1 by n is equal to x greater than 0. Now by Cauchy's root test, the series sigma un is convergent. Now by Cauchy's root test, the series sigma un is convergent for x less than 1, divergent for x greater than 1, and the ratio test fails at x equal to 1. This is the direct the direct rules of Cauchy's root test that we apply here. Because we got the answer, not a finite number, we got it as x. So we write it as by Cauchy's root test, the series sigma un is convergent. The series sigma un is convergent for x less than 1, divergent for x greater than 1, and the ratio test fails for x equals 1. So now we find, because the ratio test fails, we find out what it happens when x equals 1. What happens when x equals 1? Okay, going back, when x equals 1, we put here, the nth term will change. 1 power n is 1, n plus 1 by n by 2 power n. So when x equals 1, the nth term un is equal to n plus 1 by n by 2 whole power n. So limit n tends to infinity un. Limit n tends to infinity un is equal to limit n tends to infinity n into un. Un is n plus 1 by 2, n plus 1 by n plus 2 power n. So limit n tends to infinity. We remove n here to apply the limit n tends to infinity. Again, we bring n to the denominator. So when we remove n outside, it will be 1 plus 1 by n. We remove n in the denominator. N into 1 plus 2 by n cancels. So limit n tends to infinity. This will be 1 by infinity 0, 2 by infinity 0. So 1 by 1 is 1. Okay, 1 by 1 is 1. Okay. Now limit n tends to infinity. 1 plus 1 by n whole power n. It will be limit n tends to infinity. 1 plus 1 by n whole power n. 1 plus 2 by n whole power n. Now we have to use the formula from your basics, PU level basics in limits. Limit n tends to infinity, 1 plus x by n power n is e power x. See the formula correctly in limit, because we can't apply the limit so easily here. Direct limit can't be applied, so we use the formula. So limit n tends to infinity, 1 plus x by n whole power n is equal to e power. This x will be written here. So using that, limit n tends to infinity, 1 plus x by n whole power n, x is 1. So e power 1. Okay. Limit n tends to infinity, 1 plus x by n whole power n. So x is 2. So e squared. So e by e squared will be 1 by e. E by e squared will be 1 by e. E by e squared will be 1 by e. Okay. Now it's a very simple. Again I repeat, what happens here is, see, when x equals 1, the test fails according to the Cauchy root test. But we can't leave the problem there. We try to simplify it. So what we do, we put x equals 1 in the nth term. We put x equals 1 in the nth term. That is here. Here, un. Un is n plus 1 by n plus 2 whole power n x. But put x equals 1. 1 power n is 1. So we get un is equal to n plus 1 by n plus 2 power n. So to use the necessary conditions, the beginning of this concept, beginning of this, before Cauchy's root test and before D'Alembert's ratio test, I given a necessary condition and solved 2 or 3 problems in that. So by in order we use that necessary condition. For to use that necessary condition, we find limit n tends to infinity un. Okay, to use that necessary condition, we find limit n tends to infinity un. So limit n tends to infinity, this un we simplify how? N outside, 1 plus 1 by n, Here also I bring n outside 1 plus 2 n, you know, because this is the concept for limit n tends to infinity power n. So this will be now limit n tends to infinity 1 plus 1 by n power n divided by 1 plus 2 by n power n. And then to evaluate this limit, we use this formula written here below. Since limit n tends to infinity 1 plus x by n power n is e power x. This is from the PU level. So using that here, limit n tends to infinity 1 plus 1 by n power n. Here x is 1, so it is e power 1. Here limit n tends to infinity 1 plus x by n is 2. So we get e power x, that is e squared. So we get 1 by e. Now limit n tends to infinity un, we got 1 by e, and 1 by e is certainly not equal to 1 because e value is between 2 and 3. Because e value is in between 2 and 3, limit n tends to infinity un is equal to 1 by e, which is not equal to 1. So by necessary condition, so again we use the when it's not equal to 1, what happens? We use that necessary condition. By necessary condition for convergence of positive term series, by the necessary condition for convergence of positive term series, the sigma un is convergent. So if it's not equal to, if it's equal to 1, it is convergent. If it is not equal to 1, sigma un is divergent by necessary condition. Therefore, by using the same necessary condition of positive term series, the series sigma un is divergent. So in this case, it will be divergent. Thus, the given series we can say converges for x less than 1 and diverges for x greater than 1 and also equal to 1, and diverges for x greater than or equal to 1. Therefore, the given series converges for x less than 1 and diverges for x greater than or equal to 1. So practice this, write and study, write it 2-3 times. Still you don't understand, you can ask me later when you come to college or through call or through message, the group. But you have to try, you have to practice. Okay, we'll go to a little more bigger problem. Little more bigger problem we'll try to solve now. Here, okay. So now here, discuss the nature of the series. It is given like this. Discuss the nature of the series. 2 squared by 1 squared minus 2 by 1 whole power minus 1. 3 cubed by 2 cubed minus 3 by 2 whole power minus 2. 4 power 4 by 3 power 4 minus 4 by 3 whole power minus 3 plus etc. till infinity. So discuss the nature of this series they have told. Now sigma un will be this series only. When you are writing sigma un, it will be same thing. This full series will be sigma un. Sigma un means the complete series. Now you have to think how to write, how to find out the nth term. This is sigma un, okay. But they have not given un nth term. So how to find the nth term? So here you can see first term. In first term there is 2. In first term there is 2. That means 1 plus 1. So the nth term will be n plus 1. And the power is also in first term 2. First term the power is 2. So n plus 1 power n plus 1 divided by first term, that is n whole power n plus 1 minus first term. So first term n equals to first term, so n plus 1 divided by n whole power. First term minus 1, second term minus 2, third term minus like that, so it minus n. So very simple. This is a simple logic, by logic. Here now formula is used like arithmetic series formula, a plus n minus 1 into d, or geometric a into r power n minus 1. Nothing is used. It is just by common sense. Seeing the first term, seeing the second term, seeing the third term, which pattern they are following, that way we write it. Then limit n tends to infinity un, once you get un power 1 by n, limit n tends to infinity n plus 1 power n plus 1 divided by n power n plus 1. We apply the limit for this. Minus n plus 1 power n minus n whole power 1 by n. That is Cauchy's root test. Now how we simplify it? Limit n tends to infinity. This will be n plus 1 power n plus 1 by n power n plus 1 minus n plus 1 by n. These powers can be multiplied. When they multiply, n into 1 by n get cancelled. So it is power minus 1. Very clear. Go on cancelling, simplifying it. Then finally apply the limit. Now what happens here? You can see here. After this is written, then now we have to simplify it. So limit n tends to infinity. N plus 1 power n plus 1 can be written as n power n into n plus 1. You know, 2 power n plus 1 can be written as 2 power n into 2 power n. That way. This is split and written by indices rule. N power n plus 1 can be written as n power n into n. Minus, here I remove n outside. So n into 1 plus 1 by n divided by n. So in this case, what happens? Here also I remove n power n outside, because n is removed out, power n. So n power n outside, 1 plus 1 by n whole power n, minus here I remove n outside, 1 plus 1 by n, and here as it is I write. Now here this n power n cancels, remaining terms as it is, n and n get cancels. So we get limit n tends to infinity, 1 plus 1 by n whole power n into 1 plus 1 by n divided by 1, because everything get cancelled here. N power n get cancelled, n also get cancelled. Here also n and n get cancelled. So 1 plus 1 by n whole power minus 1. Now we apply the limit. You know the formula I told many times. You can see back. Limit n tends to infinity, un power 1 by n. When you apply the limit, don't write the limit. See, here I applied the limit, so I did not write the limit. So what happens here? Limit n tends to infinity. When I apply, everywhere you have to apply, 1 plus 1 by n whole power n is e. So the standard result from a PU level, or you also studied in that in your first semester maths. So limit n tends to infinity, 1 plus 1 by n power n equals e. Limit n tends to infinity, 1 plus 1 by n whole power n equals e. And limit n tends to infinity, 1 by infinity is 0. So 1 by 1 is 1, this is e. So e minus. Here again limit n tends to infinity, 1 by infinity is 0. So 1 by 1, 1, power minus 1. This will be 1 by e minus 1. This will be nothing but 1 by e minus 1. So 1 by e minus 1. 1 by e minus 1 means we can find out from the calculator what it is. 1 by e minus 1 means we can find out from the calculator, and we'll get, you use your calculators here, 0.58207. E value is in between 2 and 3. So totally it is less than 1. So if it is less than 1, by Cauchy's root test, if if limit n tends to infinity, un power 1 by n is less than 1, then by Cauchy's root test we can say that the given series sigma un is convergent. We can say that the given series sigma un is convergent. Okay, that was a method of solving that problem. So whenever x comes out to do, whenever this comes out to do, all this, put it in the nth term, how to use the necessary condition, how to use the Cauchy's conditions, all this you should know, Cauchy's root test conditions, etc. or D'Alembert's ratio test condition, etc. Now we'll see this problem. Seventh one, discuss the nature of the series. Discuss the nature of the series. Question is, discuss the nature of the series 3 by 4 into x, 4 by 5 squared into x squared, 5 by 6 cubed, etc. to infinity. X is positive, they have given x is greater than 0. Okay. To write the nth term, 3, 4, 5. So first term is 3. That means first term is 1 plus 2. Second term is 4. So 2 plus 2, 4. Third term is 5. So 3 plus 2. So naturally the nth term will be n plus 2. So un equal, this is sigma un series. So the nth term numerator will be n plus 2. Coming back again to the denominator, first term is 4. That means 1 plus 3. Second term is 5. That means 2 plus 3. Third term is 6. That means 3 plus 3. Like that. So we can say nth term will be n plus 3. And first term whole power 1, second term whole power 2, third term whole power 3. So nth term will be whole power n to x power n, because first term x power 1, second term x squared, third term x cubed, nth term will be x power n. Now we apply the limit for this. Limit n tends to infinity, un power 1 by n. Limit n tends to infinity, n by 2 by n plus 3 whole power n into x power n power 1 by n. So what happens? This a into b power m, a power m into b power m, n and n get cancelled, n and n get cancelled. You know how to simplify by using the rules of indices, which you studied in 9th standard and etc. So now here when this n and n cancels, finally you are left with limit n tends to infinity, n plus 2 by n plus 3 into x. This type of problem you have solved many problems. Now when you apply limit n tends to infinity, you have to bring n to the denominator. So naturally you are left with the only one method, that is you have to do remove n outside. What you are doing here, remove n outside. Okay. So when you remove n outside, you will get n outside 1 plus 2 by n. When you remove n in the denominator, n into 1 plus 3 by n into x. So when you apply the limit, after that, when you apply the limit, don't write the limit. So when you apply the limit, 1 plus 2 by infinity, this will be 0, 3 by infinity will be 0, so 1 by 1 will be 1 into x. So we got now limit n tends to infinity, un power 1 by n is equal to x. So we got limit n tends to infinity, un power 1 by n equals x. So now we use the properties of Cauchy's root test, or the rules of Cauchy's root test. What it says, the Cauchy's root test says the series sigma un is convergent if x, so this value what you got, less than 1, it's unknown. So if it is less than 1, it's convergent. It's divergent. The given series is divergent for x greater than 1, and the test fails for x equals 1. So we got x, the given series is convergent for x less than 1, divergent for x greater than 1, and the test fails for x equals 1. So when x equals 1, then what to do? So in the un term, see here, un term, we put x equals 1. So when we have to check what happens when test fails. Okay, we have to check without using the test, using the conditions. So when x equals 1, what happens? Un is equal to n plus 2 by n plus 3 whole power n. Yeah. When x equals 1, un equals n plus 2 by n plus 3 whole power n. So then we apply limit n tends to infinity, un, apply both sides, limit n tends to infinity, remove n outside 1 plus 2 by n, remove n outside 1 plus 3 by n whole power n. N and n get cancels. Limit n tends to infinity, 1 plus 2 by n power n divided by 1 plus 3 by n power n will get. Okay, 1 plus 2 by n power n and 1 plus 3 by n power n. Okay, now use this result I gave many times. Limit standard result from a PU level, or also you used it in first semester mathematics M1. Limit n tends to infinity, 1 plus limit n tends to infinity 1 plus x by n whole power n is equal to e power x. Limit, again I repeat, limit n tends to infinity 1 plus x by n whole power n. Okay, limit n tends to infinity 1 plus x by n whole power n is equal to e power x. So limit n tends to infinity 1 plus x by n whole power n, x is 2, so e power x, e squared. Limit n tends to infinity 1 plus x by n whole power n, x is 3, so e power x, e power 3. So e squared by e power 3 is 1 by e. Now certainly limit n tends to infinity un, 1 by e is not equal to 1, because e is the value, its value is in between 2 and 3. So it's some decimal. You can calculate exact value by using your calculator. So it's not equal to 1. By the necessary condition for positive terms, for the convergence of positive terms, by using the necessary condition for the convergence of positive term series, the series sigma un is divergent. So if it is not equal to 1, it is divergent. If it is equal to 1, it is convergent. So now we use all this and we analyze the result now. By Cauchy's root test, we say the series sigma un is convergent for x less than 1, divergent for x greater than 1, and also equal to 1, using this, because we got not equal to 1 and it is divergent. Thus the given series converges for x less than 1 and diverges for x greater than 1, and diverges for x greater than 1. Okay, for x greater than or equal to 1. So this is what we studied today. So I will just summarize what we did today. So we started by solving the homework problem which I given the last class. Most of you are not tried, I don't know. Be serious in your studies, write the notes, mathematics, solve the problems. When you solve it 2-3 times, naturally it will understand, you will understand. And still you don't understand, please tick it, and you can ask when the college starts, or you can ask through calls. So be very, very careful. Don't neglect. Okay, write the notes. I'm going to check the notes. Now, today we discussed about the problems in Cauchy's root test. So Cauchy's root test means limit n tends to infinity un whole power 1 by n. Now there we have seen different methods of solving the problem. First, the given series sigma un to infinity, we write the nth term. Nth term can be found out either by, if it is arithmetic series, arithmetic formula, arithmetic a plus n minus 1 into d formula, if it is geometric series, a into r power n minus 1 formula, etc. Otherwise, use your common sense as you write the nth term. Then use un power 1 by n, apply limit n tends to infinity. And whenever there is limit n tends to infinity, we have to bring n to the denominator. So that, because limit n tends to infinity, 1 by n is 0. Because 1 by infinity is 0, like that. Or 1 by n squared, 1 by n cubed, etc. All zeros. So using that conditions, we have solved many problems. Once you get x in the answer, we use the condition of Cauchy's root test. It's convergent for x less than 1, divergent for x greater than 1. But for x equals 1, the Cauchy's root test fails. Even in the DL number, same thing. So what we do, we cannot say it fails here. So we put x equals 1 in the nth term. X equals 1 in the nth term. Here we put x equals 1 in the nth term and find un. And then apply using the necessary condition, use limit n tends to infinity, solve it. I will get the formula is there here, that's 1 by, and it is not equal to 1. So by the necessary condition, if limit n tends to infinity, un is equal to 1, it is convergent. It's not equal to 1, it is divergent. So here it is not equal to 1, so it is divergent. So now we analyze this result, that is by Cauchy's root test, the series sigma n is convergent for x less than 1, divergent for x greater than 1, and also divergent for x equal to 1 we got here. So we combine it and write the series sigma un is convergent. Thus the given series converges for x less than 1 and diverges for x greater than or equal to 1. Practice this. We will solve some more problems in the next session tomorrow at 11. Okay. Once again, I am requesting you, all of you, write the notes, work hard. Any doubt you can ask later, and do the assignment 1. Okay, in the A4 sheet paper. Write the notes in the notebooks as you are writing before module 3, module 4, like that. Okay. And I wind up the session now. Thank you. All the best.